AI is changing everything, from how businesses make decisions to how machines understand language and images. But here's the truth nobody talks about. AI can't work without data mining. It's the process of digging through raw data to find the patterns that make AI smart. This video course is Introductory Data Mining. The book the material comes from is Data Rookies, Data Mining Basics, available from Data Analytics Curriculum LLC and can be direct downloaded from the website. In addition, there are supplements and lab exercises for download. Chapter 4: Cluster Analysis. Cluster analysis is an unstructured learning data technique that groups a set of objects so that objects in the same group, or cluster, are more similar to each other than to those in other groups. Chapter 4, Section 3: Normalization and Scaling. In this section, we'll look at normalization and scaling, key steps to make sure our distance calculations are meaningful. Learning outcomes. By the end of this lesson, you should be able to explain why we scale or normalize data in data mining. Understand how different measurement units, like pounds versus kilograms, can change the way distances look. Describe what a z-score is and why it's useful. See how unscaled data can lead to misleading clustering results. And know that most data mining tools can normalize data for you automatically. Why normalize data? Data often come in different units like dollars, inches, or kilograms. If we don't normalize, these different units can distort our distance calculations. Why normalize data? Example. Here's a simple example. If one person weighs 180 pounds and another weighs 160, the difference is 20. But if we convert that to kilograms, the same difference becomes 9. It's the same two people, yet the distance looks completely different depending on the unit. That's why scaling matters. Why this matters in clustering. Clustering depends on distance. If one variable has a larger scale, say height in inches versus weight in pounds, that variable can dominate the distance calculation. The result is misleading clusters. Visual example: height and weight unscaled. When we plot unscaled variables like height and weight, their different units make distances uneven. Some clusters might appear just because one variable uses larger numbers. After normalization. After normalization, we convert values to z-scores. This standardization removes unit-based distortion so distance calculations are fair and balanced across all variables. What is a z-score? A z-score tells us how far a value is from the mean in terms of standard deviations. The formula is simple: z equals x minus the mean, divided by the standard deviation. By converting all variables to z-scores, we ensure they are all on the same scale. Tools that handle normalization. Most modern data mining tools handle normalization automatically. Examples include Orange, RapidMiner, and KNIME. But tools like Excel or some basic statistics programs may not normalize by default, so it's important to check. Why it's essential. Normalization ensures a fair comparison between variables, avoids misleading clustering results, and makes distance matrices accurate and consistent. Without it, your clusters could reflect unit differences instead of real patterns in the data. Remember, the book and supplemental resources are available online at Data Analytics Curriculum's website.